Hey guys, we're going to talk today about weathering and erosion as far as rivers go. You've already looked at glaciers. Glaciers are the most powerful weathering and erosion agents, but we're going to see that water is actually the most important and the most active weathering and erosion agent. It's constantly eroding anytime the rain falls. When it hits the ground, it's starting to weather and erode some of the stuff there. Water flowing can actually wear away rock and soil, dissolve it, carry it to new places. So water is pretty important because it will do all the weathering, all sorts of erosion, and it does deposition eventually when it slows down. So rocks and sediments in a river can kind of scrape against the rock that's already there, break it into smaller pieces, and this kind of increases our weathering and erosion and deposition rates. A couple things: faster water will be able to pick up heavier stuff, carry it with it. So faster water is going to be doing more erosion, more weathering. Slower water actually promotes deposition. So, and just so you guys know, steepness of the slope is going to affect the speed of the water. So places where the water is going more steeply, so like at the top of mountains, it's going to be able to pick up more stuff. It's going to be doing more weathering and erosion. When it's more of a flat area, that's where we get deposition. Deposition happens like at the end of the river's course usually, and we'll take a look at that in a second. But water helps with chemical and mechanical weathering. So if you take a look at this diagram right here, it's a pretty common picture to just demonstrate the life of a river. If you look up here, we have some kind of a source. Usually glaciers are the source of water for rivers. They melt. They have some steep areas up here, even more steep, but eventually when they settle down to a little bit lower areas, it starts getting flat, and they start to do this thing called meander. They kind of twist back and forth. You get all sorts of different things called sandbars, and you get oxbow lakes. Like this is an oxbow lake. We'll get into that in a moment, but at the end, eventually they start depositing their material in areas like deltas, estuaries, and that eventually can form new dry land and rock later on. So, like we said, it starts as a glacier melting. Water flows downhill due to gravity. It can actually do some of the same stuff that glaciers do, like carving out great big valleys or what looks like valleys. This is how we get the Grand Canyon, actually. All this weathering, erosion that happens over time, and the Grand Canyon carved it out just from rivers and a couple other geologic processes. But the farther down you are and the flatter the land, things start to kind of curve back and forth. They're moving more slowly. Water always wants to find the lowest point. So the course that it follows is just going to continually be wherever the lowest points are. So if you look at this, we're going to go through this one a little bit more slowly. We have this river right here that is curving. So we're in a little bit farther downstream. At the points where the water is kind of coming out, like right here, it's going to hit all of this edge of this bank, and it's going to do a lot of cutting. It's going to cut into it, weathering and erosion stuff. So the water is faster out on these curves, but on the inside curves, it's actually slower. So we get deposition here. So we can have these little point bars that grow farther and farther out. These places get cut more and more. And then if you are coming around here, it's cutting here. So the outside curves are getting cut. Eventually what happens is we can cut so deeply right here, and then eventually we're cutting on the curve right here as well. These 2 points will meet up, and you get this little island right here called a sandbar. Or not a sandbar. So you get this little kind of point bar right here. The life of a river is pretty strange because they will kind of move and change their course, and we're going to look at that in just a second. But they create things like floodplains. Those are big, wide areas where flooding has happened, and all this erosion and deposition and weathering has occurred, and they create levees, and we'll take a look at those in this next slide, actually. But before we do that, I want to take a look at a video that shows kind of the life of a river. This is something called a sand table, and I'm going to blow this up for us. We're going to watch this for just a little bit, and I'm going to try and condense the time down here. So. Okay, what we just saw there was kind of the life cycle of a river. I wanted to point out a couple things. So it starts to curve back and forth and back and forth. And you can even see in this diagram right here, the areas where we have the curves or the outside of the curves, we start getting cutting, okay? So it cuts deeply. Eventually it starts cutting so deeply that one side will connect with the other. So if you look at this diagram right here, eventually this is going to cut out here, it's going to cut out here, and we start getting these places where it will cut across, like down here. This is a channel cutoff. This is one where it was going so fast that it started to curve or cut its way across here, okay? When it was coming around this side, it started to cut its way across here, and it eventually met in the middle, and you guys saw that in the diagram, or the video that we just watched. But a couple quick things. When you look at this, you guys notice there's a big wide open area, and on both sides of this, the ground's a little bit higher here. This whole lower area is called a floodplain. So when rivers get a lot more water in them, they will flood over their banks, and we kind of get these big wide areas. More water in the river makes it typically go faster, but as soon as it overflows its banks, the water that overflows the banks of the river is going to kind of settle down, and all the mud and everything it was carrying is just going to settle there. So we get these nice flat floodplains around the river, and they can be miles wide. They're pretty big. They're not small. So, but a couple things. Again, outside of the river, it starts to cut out on the outer edges, on the inside edges, because the water is going slightly less fast. It's going to deposit. So on the inside curves, you start to get like point bars, sand bars, that kind of stuff. So again, Oxbow Lake, when it's flowing through here, cuts on these areas right here on the outside of the curves. On the inside of the curves, it's going to be depositing. It has this nice little key for you guys to see that. Remember, when water is going faster, it's going to do weathering and weathering and erosion. When it's going slower, it's going to deposit stuff. They form these things called oxbow lakes. So if you guys see the transition here, it's cutting here where these triangles are. It's depositing more stuff where we have some of these little dots. Eventually we get deeper cutting here, and then it eventually cuts off, and it'll create a straight course here, and then this nice little abandoned lake called an oxbow lake. But let's look at some real life pictures here. This is the Mississippi River. You can kind of see the line in between Arkansas and Mississippi. If you follow this around, it mostly follows the Mississippi River, but when you get up here, it starts to not quite follow the Mississippi River's current course quite as much. If you look here, the Mississippi River now goes around in here, so we've got places where it's cutting across again. Because the river moves, originally when we made the state lines, we were following the Mississippi River. So as the river has changed course after areas where it's flooded, it has also caused the state line to basically go from one area to another. Let me rephrase that. The state line's not moving. It's just people who were once on one side of the Mississippi River in one state find themselves on the other side of the Mississippi River, but they're still in the other state. So unfortunately, we don't move our state lines when the Mississippi River moves, but it's just kind of interesting to see some people get cut off. So if you see like right here where my mouse is, the Mississippi River looks like it used to run through there, okay? But now it's filled in with all this sediment. It doesn't quite run there anymore. You can totally see that. If you look at kind of the relief of this, you see how you can almost make out a line here. This is a higher area. These are lower areas. These areas have been filled in with sediment. This is where the river used to be. So let's take another look at another one. This is of the Missouri River. You can see that water creates these deep scarrings of the landscape whenever water falls, during rainstorms. It'll find the low points, cut out those low points like you can see right here. This is where it started to cut. Eventually, it makes its way down to the main course of the river. It's very windy in here. You can see there's like this flat area right there where the river has kind of wound back and forth, and it's just kind of widened that whole floodplain out. You can see that happening. Now, near the end of the river, we slow down. We have tons and tons of sediment and rocks that have been picked up along the course of the river, and that stuff all gets kind of just laying down, deposited. When it deposits, it creates deltas. After long periods of time, it'll eventually build up, create rock, and we actually have, like, around Egypt and the Nile River, you get this area that has built up. A lot of this stuff would not be here without the deposition of all those sediments. Also, Mississippi River goes right through here. All this stuff that is really colorful in here, some of it's pollution, but a lot of it is actually sediments and everything. So if you look at that, eventually the Louisiana area is going to get more land, probably because it's depositing a lot of sediments down there. So you get new land. Now, most of the time it's marshland, but over long periods of time it turns into rock. So over on the west coast, where it's very rocky, you get cool cliffs and things like that. Rivers and water erosion create things like the Grand Canyon, waterfalls. If you look over here on the sides of hills, you can see these little scars in the side. Those are called rills. That's where water flows down. So a couple things. What should you know? How does water speed affect weathering and erosion? Faster water causes more weathering and erosion, and slower water causes deposition. So that kind of answers our second question here. Where would rocky river bottoms be, and where would sandy, silty bottoms be? Think about this. Rocks are big, they're heavier, so what kind of speeds would we have to pick them up? Where is the sandy, silty stuff going to be? Remember, if it's slower, it's going to be deposited, so we'll have more silt in the slower areas, less silt in the really fast areas. And then a couple other things. What affects water speed? The slope of the river, and also the amount of water in the river. So this doesn't cover every little thing with water erosion and weathering stuff and deposition, but it's a good example, and you'll probably see a lot of it on the test. So if you got any questions, come talk to me, and I'll be happy to help you out. So talk to you later.